Hello. How is everyone today? All right. Let's see. Let's check the font size. Seems good. Okay. All right. So at this point, we are tracking content that is being written to the wall log, and there's different ways that we could detect that a transaction has been written to the wall log. This one, though, we can tell that a transaction has been written because a commit page has been written. When a wall frame header has been written, I don't know I have that there. Probably just checking, debugging something from long ago. So when a frame header has the number of database pages in the database set to a non-zero value, a commit page has been written. And that means it's done. So I think at this point, we would send a message to data plane telling data plane which file, right, and then what the start and stop, beginning and end of the transaction are on disk. Along with the DB page info. Does it really need that? I think so. Let's check data proto. You have yet to define it. Okay. Instead of sending the memory as we are writing a large transaction, we could just send memory across. Right here, we just have a void pointer. It's going to be so many bytes. These writes will typically be in, 4K-ish chunks. and page size. Now, fsync doesn't happen regularly. If we look at one of the writes, file size, I thought I had a write here somewhere. Thirty-two, 24, and then a 4K chunk, 4K chunk. Oh, this is a read. Here's a write. Oh, that one's a write. This one's a read. And it looks like sync happened. Hmm. Close. Oh, that must have been the process stopping. Oh, this is all one log. This is the dot current. Times, yes, the times are different though. Okay. So at this point, we want to get access to right to the FIFO. The FIFO is going to be monitored by data archive, sorry, data plane. That's the connection that we'll have between the two. I didn't want to use a socket. I wanted to use something that was quick. FIFOs are pretty darn quick. So, oh, and I also wanted to have something that I could write to from many processes. Right. It's possible that this VFS will open many databases, and each of the VFSs will write at different times. And a FIFO, if the data is small enough, you don't have to worry about locking. I say LEV, LEV. Interleaving arrays on FPGA. What is NI? Let's say a POSIX. What are guarantees for concurrent writes into a named pipe? Yes. Let's put that in dark mode. It depends on how much each process is writing. Requests to a pipe or FIFO shall be handled in the same way as a regular file with the following exceptions. Write requests of that many bytes or less shall not be interleaved with data from other processes doing writes on the same pipe. Beautiful. Writes of greater than that may be interleaved. Okay. A write is atomic if the whole amount written in one operation is not interleaved with data from any other process. This is useful when there are multiple writers sending data to a single reader. Exactly what we have. Applications need to know how large a write request can be expected to be performed atomically. The value of pipe buff is defined by each implementation, but a minimum is 512 bytes. See limits.h. Well, that's more than enough for us. On Linux, it's that. See pipe 7. Yeah, okay. Let's take a look. Oh, hello. Value 512. Okay. This is probably also going to be bright white. Yeah, let's change that. That works for me. Nice that I used a to do there. Normally I use a fix me. I must have been in a different state of mind that day. Now, how do we get there and what do we send? Let's rough it out. File, amount. We want the beginning and the end of this. How do we know what the beginning is? We would know what the beginning is because it would start with. Hmm. Or do we want data archive, data plane to deal with that? Because it will just go from the beginning to the end of the file. Trying to think of edge cases. So when an application starts up, the wall log is pulled into the database. So we should always be in a state. Always be in a state where excuse me. We should always be in a state where data plane is at the most current transaction head. If not, it would just seek. Hmm. I don't know. It would be nice though. Would be nice. Let's get rid of those. Like that. Okay. So we would store this information on our VFS file object. Oh, we call it a reverb file now. State. Interesting. I wonder if we could have different ones for different types of files. Set that to use size, an optional use size. An option so that we know if it's not set. Essentially, we're going to send it a range. What is this going to look like? What is it going to look like? Let's say start position, end position, PV pages, and it needs to know which file. File name. And this all has to fit in 4K. So it could put a maximum on the file sizes that these are allowed to open. Could set it to like 3K. What about a checksum, like a file name checksum or something? Something that can represent the file, but not be a giant file name. That would work. That might keep us under the 512 byte limit. That'd be nice. Start data, start position, end position. It's going to have to parse this anyways. Why send the end position? Or the DB pages? We might want to send the DB pages up front. Say there will only be this many database pages at the end of this operation, instead of doing it at the very end. It's typically not how SQLite works, though. End position, database pages, file name length. Okay, so far, what I like is. What did I do? Did I hit? How did I get to that spot? Hmm. Oh, I hit tab. Strange. I don't know what tab does. Anyhow, yeah, if I hit tab there, I go to some other location. I don't know why. What does tab do in Helix? Next entry? No. Picker? No. We're not in a completion menu or a picker. All right. No idea. Data to send. Let's send the start position and the some sort of hash of the name. What has fewer collisions or hashes? We could do like a SHA 256. Might be overkill. Collision. I spelled collision wrong. Hello. 5 seems like it would be enough. Yeah, we're not looking at that. For file integrity, okay, MD5 of file name. Do we need to send the shard? Does this need to understand the shard? Or can data... Yeah, what is a shard in this case? Sure, we can add that if it's needed. I'm not sure how we would get it at this point. It seems like it would be an environmental property. This application is dealing with these files. They are in this shard. A data archive could know the same exact thing. Okay. Let's start there. How do we get an MD5 of the file name? And Rust dependency. Wait. Ooh, hello. Let's see something real quick. Cargo build -p. Okay. Is this all because of FlexiLogger? Saturday, maybe? Can't be. I just want to see how large the VFS is. Okay. 1.5 megs. Mm, that's fine. It would be nice if it was much smaller. So we're not doing all that much in VFS. Is this empty file? That's right. I was going to have some sort of stream set up. Source main. This does nothing. Okay, let's remove a couple of these real quick. Okay. Good. There is not much here. Most of these are just pass-throughs. We have a handful of structures and dependencies. libc, that could be large. DB mutation. What does DB mutation do? Oh, I see. I was planning on sending stuff. Do I work with? Oh, morning, Parmesan. Do I work with SQL on a daily basis? I do not. I do. I used to. I would say I'm rusty, but shh. All right. So if this is really just going to be the data sent over the named pipe, I don't. I was just going to use just a constant byte stream, fixed size, read so many bytes at a time. Do I want something more sophisticated? Not really. We could use postcard. We use it elsewhere. Resource efficient. Stable wire format. Blah, blah, blah. Okay. We could use this and just have a common struct. What do we want to call this change? Something. Call it something for now. It has a file. File name checksum. No, not a checksum, MD5. And what do we have already pulled in that we could do a MD5 checksum with? Mm. Oh, what about just a hash, 2x hash? Where am I using that? Oh, that's right. 2x hash was used for the node IDs. Hmm. Feature flags. Okay. XX hash 3264. I want to see the properties of them. Maybe here? No. Benchmarks, maybe? Hmm. Interested in. I don't need speed. This will be done once. Updated over 5 years ago. That looks like the go-to. Use digest. These are traits. Scripto hashes for implementations which use these traits. I see. Supported algorithms. Wow, so many. I was thinking something like 256 just because gives us a lot of space, low collision. Let's just pull that in. Dictation here. Let's use the SQLite terms. db commit. That's a commit. File. As, I don't know, a vector of bytes. So we could do an array. If we do SHA-256, then it's always the same size. Still, we have the starting position. Anything else? No, it's gonna know. Let's make these public. Let's add some documentation. Okay. And if data archive receives a hash that it doesn't recognize, it scans the directory. Should be all right. Hmm. We'll have to make sure that's staying up to date because the file name changes when the wall log is checkpointed back into the database. Okay. Oh, and Turtle Waves. Thank you for the follow. Let's create a new for this. It's going to be like that. Let's have a file name. Hmm. What does data archive have? It has a string. I was thinking, should it be a path buff? What should it be? All right. So how do we use SHA-256? Finalize into generic array. It's a generic array. Works like one of those. Hmm. You know what? We don't want to generate the SHA whenever we have a commit. This should be. We don't need a new for this. should just be that. We just copy it from something that already has. Okay, back to VFS. Here, we have a file name. That's where it's created. Oh no, that's we're freeing it there. Okay. Pass through. We're okay. Drop. It's not really important, is it? Open file. Here we go. Where is this called? That's at the end of the wall rotation. Take salt. Where does that get created? Is it in BFS? I don't think it's file. I think it's here. So X open. It must be in here. Because at this point we do get the file. Well, the file name. File flags. So it equals something here. All right. Let's get a new hasher. Does it update? We give it some data. That's a. Doesn't need that either. And that goes away. I don't know why we have an error. Can we get rid of snafu as well? Probably. Okay. Import that. File name that we have. It is pointer to i8s. Now, is it guaranteed to be? Let's see. SQLite did mention what it's some guarantees around that. SQLite. Loadable extensions maybe in here. Open a file handle. That's not it. Let's just go to the docs. Database file name UTF-8, UTF-16. Could it be UTF-16? Guessing everybody's going to use UTF-8, but I'd hate to introduce a bug. It's either a null pointer or a string obtained from blah, with an optional suffix added. Okay. It will be valid and unchanged until xclose is called. You can store the file name. We don't know what it is. Okay. So maybe it describes it somewhere. Number of bytes. No. Okay. So let's just treat it as, goodness, what could we pass to here? As ref. As ref. T for T. Okay. We don't want to do as bytes. We just want data. Slice from raw parts. Oh, interesting. Transmute. Oh, the transmute documentation has some good tips on it. Raw bytes into different things. Turning a pointer into a usize. And alignments have to match. Where was it from? From array. from bytes. No, that's not. The element's not the number of bytes. Okay. Z name. Oh, we have a function Z name to file name. Oh, interesting. Is it a C stir? Hmm. It was like UTF-8. We just figured that out. Or UTF-16. We don't know. Where is this used? Nowhere else? Really? Hmm. Well, let's get rid of that then. It's probably not safe. From raw parts, so we have Z name. We don't know how long it is. What we do know is that it is terminated. It's null terminated. Yeah, could be in UTF-16. Let's put a link to that doc that said UTF-16. What was that? Here's X open. Wait, it says it's a SQLite 3 file name. What is that? That this is different. Really? Ah, fine. No, that's right. and whatever this happens to be under the hood. Why don't we just replace that then? So if this is a file name, if it's some sort of null terminated bytes, how do we get to the end of that and know what to like this? I know what I would do in C. How do we do this in Rust? Imagine we could just use some libc function. Sterling. That might work. Except it's not. This should work. Let's try it. Expected raw pointer found raw pointer. Oh. Hmm. It's not it. Here we go. Okay, I did have the interface wrong. The rest is correct. Right, so now we have a slice to an I8. I'm surprised. That works for me. Now, can we use the I8? Bytes, okay. It doesn't like I8s. Let's cast that to U8s. We want to transmute Z name into that. Should be identical from parts. Mm, let's push that error up. Why is it trying to go? Oh, because I didn't change the input. Okay. All right. So we get that, and I think I'm just supposed to call like finalize or something. Finalize into. Let's do that. Now we have to give it the right data here, the right inputs. What is that? That is, oh, this is going to be unsafe as well. This will be reverb file dot file name. Multiple applicable items in scope. Oh, hmm. Mismatch. Expected mutable reference found array. Ah, expected. No, that's not what we agreed to. How do we get a mutable generic array? I don't want to give it that. We just finalize it, get some output, and copy it over. Let's do that. Finalize. The generic array. Okay. Really? 2. I want SHA-2, not SHA-256 here. SHA-2, hasher, update, finalize, generic array. has SIMD. Hmm. So we could get a slice. Validation of known-like generic arrays can be done via the ARR macro or from array from slice. Convert into a generic array. We can go into array. Okay. There it is, into array. No, we can't do that. We need to copy this over there. The memory is already allocated. Wise copy. It's literally defined as nightly experimental. Copy from slice. Hmm. What else can we do with a generic array? I saw an iterator. CT variable core wrapper. SHA-256 var core. Okay. Is into finalize fixed. Will that make a difference? We just treat it like a slice and copy it over. Mm, slice. Let's do that. Copy from slice. Copies all elements from source into self using a memcopy. Sounds good. Okay, that might have worked. Let's try it. Debug. Let's do that in here. Oh, good. Is it hard for you to share Helix config? Um, not, I don't know. Morning, Learny. Um, the Helix config. Interesting. I don't think so. I mean, this is all it is. This and the language file. There you go. Yeah. And then just this. I had been playing with trying to get a um, Olama working with Helix GPT, but it just became distracting. No errors. Let's get this in build. Let's check real quick. So that works. Let's run it. Let's see if it panics. I like to make small changes when using unsafe Rust. Source length. Source slice turns up. Oh, interesting. Yes. It's 256 bits, not bytes. Oh, that's an easy fix. Is it is it in file? Here it is. Beautiful. Okay. So now we have identifiers for the file names. We'll have to keep a list of identifiers in the other application as well. probably with a hash map and whatnot. Okay. So now that we have that, when no, we rotate the wall here, we need to send something to the FIFO. All right, we have 10 minutes. How do we do that? Let's get rid of some of this. Oh, we don't have the start info yet. All file header. No, we don't want that. Although we do have to deal with that. Frame header should have been written. And if it's basically we have the version that is the end and the version that's the beginning. So if it's 0 and whatever the file object, am I using custom errors? Good morning, Batman. Glad you could show up here. Uh, we are using Snafu for our error handling. I like the way that you chose the color for your handle. It's nice. All right. File frame. What do we want to do here? Take salt. So here we have basically an interface to our object, right? Our reverb file. It does the conversion for us, does all of the interesting underlying bits. So the rest of our code can look more sane. Like rotate wall. What do we mean by that? Take salt, set salt. So I might need something similar for the start. Right? So we need to commit start position. Let's rename that to just commit start. Oh, and we should really initialize that. Still doing this replication thing. We'll be doing the replication bits until the replication bits is done. Then we'll be doing the website bits until the website bits is done. And then we'll be doing, well, you get the picture. And happy Thursday. All right. Commit start. Let's see. File. Does this get set to nothing? No, it doesn't. Maybe I should have like an init on it. Something that just goes through and sets it all to nothing. Not a bad idea. What do we want to do in a knit? As I said before, set everything. All right. It's kind of like our constructor, but the memory is already allocated. And if we go back to here, this is kind of where our initialization is happening. I feel like some of this should be moved into there. Yeah, here's our reverb file, or just the file. Flags and name. So now we have our reverb file. Good. See name and flags. Then most of this goes away. Mm, that can move up though. Yeah. What are the other properties? Let's start. File start. Okay, we have these three are done. These two are not. File start, commit start. Hmm. debug. And if we move our init down, I believe we could include more of these in the initialization. This is actually mimicking um, some example code that I found. I think I just like it all set to 0 first. Because we are given a sqlite 3 file. We ensure that it's not null. I've got to get going. This is a good start. Who shall we raid? Right. We're going to raid Future Highway. I've got to run. So, have a great rest of your Thursday. Take care, y'all. Bye bye.